Hi students, in our last class we are discussing about Bravais lattices. How many Bravais lattices are there in nature? Total 14 Bravais lattices are there. These lattice structures are expressed in terms of three-dimensional point of view. Lattice is nothing but space lattice. Space lattice is nothing but the lattice points arrangement, periodic arrangement of atoms are expressed in terms of three-dimensional point of view. Those three-dimensional point of view, every crystal structure is existed out of 14 Bravais lattices. Out of 14 Bravais lattices, mainly 4 structures are repeated. Those structures are simple cubic, face-centered cubic, body-centered cubic and base-centered cubic structure. Out of these 4, any structure is there, entire 14 structures. So, based on Bravais lattices, we are going to the next topic, that is called as basic definitions among the crystal structures of the materials. For crystal structures of the materials, we are following to the some basic definition. Those are called as parameters determining the crystals. So, what are the parameters? You are determining the crystal structures of the material, you require some basic parameters. Those are called as number of atoms per unit cell. This is also simply called as effective number. And second basic definition is atomic radius. Third one is called as coordination number. And fourth one, packing factor, otherwise simply called as packing density, otherwise density packing. These 4 are very important terms regarding the crystal structure of the material. So before going to the topic, first basic definition of basic parameter is number of lattice or number of atoms per unit cell. What is the unit cell? First of all, unit cell is nothing but smallest geometrical structure. Enter the crystal structure. The smallest geometrical structure can be taken. That smallest geometrical structure is repeated. The entire crystal structure is giving. The smallest structure is nothing but unit cell. In this unit cell, how many atoms are there? You are taking the very smallest geometrical structure. In this structure, they have 1 atom, 2 atom, 3 atom, 4 atom, anything. How many number of atoms are existing within the unit cell? Suppose I am taking this is the unit cell. In this unit cell, there existing completely 1 atom is there. The number of atoms per unit cell can be taken as 1. Some structures have 2, some structures has 4, anything. So, how many total number of atoms existing in the particularly unit cell? That number of atoms called as effective number, otherwise number of atoms per unit cell. That is the first parameter which is very important. And second one, atomic radius. Each and everyone knows you can take one atom like this. This is the atom. So the atom structure which is in spherical in structure. The shape of the atom is spherical in structure. You can take center of the atom to the distance covered on the surface of the atom. The distance can be taken as atomic radius, which is taken as smaller. Sometimes you can take as A. Basically, this is represented by atomic radius R. So, the half of the distance between any two nearest neighboring atoms which are directly contact with each other. Suppose you can take one cell, one unit cell like this. This is the unit cell. In this unit cell, the corner is occupied by one lattice. Here corner are occupied by one lattice. According to this point having directly contacted with 2 atoms side by side. From center of the atom to center of the atom, the distance can be called as atomic distance. Atomic distance. This distance is represented by D. The atomic distance is nothing but the distance in between successive neighboring atoms center to center distance is called as atomic distance. That is represented by D. D value can be taken as Here the radius is smaller, here atom radius is smaller. D is equal to 2r. What are you wanted? We are wanting to calculate the atomic radius, small r value. From this equation, small r can be taken as d by 2. D is nothing but interatomic distance, otherwise which is also termed as nearest neighboring distance. The nearest neighboring distance by 2, nothing but half of the nearest neighboring distance, otherwise atomic distance, which is called as atomic radius. So small r value can be taken as d by 2. That is the second parameter of the determine the crystal structure, that is called as atomic radius, which is simply called as half of the distance between interatomic distance of the atoms in the crystal is called as atomic radius. And third one, coordination number. Coordination is nothing but, each and everyone knows coordination, mutual understanding, mutual sharing. That is the meaning of coordination. That coordination is expressed in terms of number. What is the number? Which is number is existed with respect to crystal structure. So crystal structure, every atom is surrounded by some basic atoms. Suppose I am taking the first atom. This first atom is surrounded by nearest atoms like this, A, B, C, D. The first atom is surrounded by 4 atoms, nearest neighboring atoms, surrounded by 4 atoms. These 4 atoms number can be called as coordination number. The coordinate, according to definition, the number of nearest neighboring atoms to a particular atom. You can take any atom. That surrounding number, nothing but friends, you can take as the best friends. That best friend numbers can be called as coordination number. After that, fourth one, very very important. This is also the major topic in SSP. That is atomic packing factor, sometimes called as packing density, sometimes called as density of packing. What is packing factor? This packing factor value mainly depending on atoms. Atoms are existed with respect to crystal structure. So in this crystal structure, atomic packing factor is nothing but ratio. What is the ratio? Particularly occupied volume to total volume. So the ratio of the volume gives the term is called as atomic packing factor. According to the definition, it is the ratio of volume occupied by total number of atoms per unit cell to the total volume of the unit cell. Suppose you can take as 1 unit cell like this. This can be taken as 1 unit cell. This unit cell structure can be taken as cubic structure. So volume of the cubic, the side is lattice parameter can be taken as A. The volume of the cube, total volume of the cube can be taken as A cube. In this unit cell, how many atoms are there? Suppose you can consider as some 2 atoms are there. The atom which are in spherical in structure. So this value can be taken as small v. Number of atoms 2. Volume of the sphere is nothing but 4/3 pi r cube. So small v to capital V ratio gives the atomic packing factor. Atomic packing factor. Small v indicates the smallest geometrical cell volume to the total volume. This structure is repeated, they give the total volume of the structure. So the ratio of volume occupied by the total number of atoms of the unit cell to the total volume of the unit cell. So this volume can be represented by total number of atoms per unit cell into volume of the single atom divided by total volume of the unit cell. This unit cell always be you are taking cubic structure. This volume of the atom is nothing but the atom always be in spherical in structure. The volume of the sphere can be taken as 4/3 pi r cube. So basic parameters of determine the crystal structure, mainly these values, these terms must and should be known. That is number of atoms per unit cell. Second one is atomic radius. Third one is coordination number. And fourth one is atomic packing factor. These are the basic terms. After completion of this basic term, one by one you can clearly explain. First one, number of atoms. Second one, atomic radius relation. Fourth one, atomic packing factor. So coordination number each and everyone knows. You are clearly explained. So based on these parameters, we can explain one by one. So after completion of basic parameters to determine the crystal structure, so we can explain first one. What is the first one? Number of atoms. Number of atoms per unit cell. Per unit cell. First we can explain this term according to structure by structure. According to Bravis lattices, we have 14 lattice structures are there. 14 lattice structures are there. Out of these 14 lattice structure, mainly repeated structures are simple cubic, otherwise primitive. Second one is face centered cubic structure. Third one is body centered cubic structure. These three structures are repeated structures. This simple cubic structure is represented by P. Face centered cubic structure is represented by F. Body centered cubic structure is represented by I. Sometimes you can represent it by B also. Basically you can represent it by I. So these structures. So one by one you can explain. Number of atoms per unit cell in simple cubic structure. After completion of that one, number of atoms per unit cell in FCC. Third one, number of atoms in BCC. So first one you can explain. First one, number of atoms per unit cell in simple cubic structure. What is simple cubic structure? Simple cubic structure is nothing but it is first of all a unit cell. So I am drawing one unit cell. What is the unit cell? It is the smallest geometrical structure which is repeated. They can give the entire crystal structure. That is the unit cell. So that is the unit cell. So this is the unit state which is repeated. They can give the entire structure. So this structure can be taken as simple cubic structure. So this simple cubic structure is nothing but first of all unit cell. What is the simple cubic structure? Simple cubic structure is nothing but every unit cell corners are occupied by lattice points. So I am taking atoms. So here one lattice point is there. One lattice point. So how many corners are there? Entirely 8 corners are there per cubic structure. So here 8 corners are there. Like this. So this is the simple cubic structure. This simple cubic structure is repeated. They give the entire crystal structure. Based on this structure, every corner atom is shared by nearest 8 unit cells. 8 unit cells. Nothing but every corner. Suppose you can extend the structure like this. So another unit cell is there like this. This dotted cell is also the unit cell. So here corners are occupied. This atom is existed left side unit cell as well as right side unit cell. This is also in a similar fashion. Every corner atom is occupied by or is shared with nearest 8 unit cells. 8 unit cells. So what is the portion of every atom per unit cell? Per unit cell every atom is, suppose this unit cell, this atom is shared with 8. So particularly this unit cell have how much amount of portion is there, 1 by 8th portion is occupied by unit cell. Here also 1 by 8th. In a similar way, 1 by 8th, 1 by 8th, 1 by 8th, 1 by 8th, 1 by 8th. So totally 8 atoms are there. So every atom is occupied within the unit cell portion is only 1 by 8. So total number of atoms per unit cell is equal to, you can write like this, the portion of atoms sum, nothing but you can write 1 by 8 plus 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 1 by 8, 3 3 6, 1 more 2, 1 by 8 plus 1 by 8. Totally it is written by 8 into 1 by 8. 8 cancel 1. So in simple cubic structure, how many number of atoms are existed per unit cell? There existing only one unit cell is there. This can be simply written as total number of atoms per unit cell is equal to number of corners into portion of the atom at corner. So how many corners are there? Cubic structure 8 corners. What is the corner portion? 1 by 8. 8 get cancelled. There existing only 1. So in simple cubic structure, how many number of atoms are there per unit cell? There are only 1 by 8 into 8. Nothing but there is only one cubic. Only one atom is existed in the unit cell. That is the number of atoms per unit cell in the simple cubic. So simple cubic structure has how many atoms are there? Only one atom is there. Note down. So first here completed number of atoms per unit cell in simple cubic structure. How many atoms are there? Only one atom is there, because every corner atom portion is only 1 by 8th portion. Remaining 7 by 8th portion is occupied with or connected with 7 unit cells. So in a similar way, next one is number of atoms per unit cell in face-centered cubic structure. So first of all, you can draw the face-centered. What is face-centered cubic structure? Face-centered cubic structure is first of all a simple cubic structure. What is simple cubic structure? Every corner of the structure is occupied by one lattice point. So this is the, you can construct as unit cell. This construct as unit cell. Face-centered cubic structure, nothing but every corner is occupied by one lattice point. So lattice point, this is one lattice point, second, third, 4, 5, 6, 7, 8. So 8 corners are occupied by 8 lattice points, and every center of the face occupied by one more lattice point or atom. First one, second one, third one, fourth one. I am completed left, right, top, bottom. And a similar way, back portion and front portion. So here, how many faces are there? Entire the crystal structure, there are 6 faces. How many corners are existed? Corners are existed, 8 corners. This is the complete face-centered cubic structure. This cubic structure or unit cell is repeated, they give the entire crystal structure. You can extend the unit cell in the crystal structure like this. This is one more crystal structure. So according to these unit cell, you are observing this right side corner or right side face belongs to two unit cells. Belongs to two unit cell. Nothing but this right side face is acting one of the face of left side unit cell and one of the face of right side. So here center of the atom. Here center of the atom. This one is occupied with respect to two cells. Nothing but according to left side portion, this exactly half portion is acting. Nothing but remaining half portion belongs to right side unit cell. So how many lattices or atoms are existing in the unit cell? Infinite. So every corner occupied by 1 by 8. So according to corner, I am writing 8 corners. Portion of the atom is 1 by 8. Plus, how many faces are there? Totally 6 faces. Every center of the face atom is occupied by only half of the portion. Nothing but 6 into 1 by 2. Here 8 get cancelled. 6 in terms of 2 in terms of 6 3 times. So you get 1 plus 3. Nothing but 4. So in face centered cubic structure, how many atoms are existed per unit cell is totally 4 atoms. 3 atoms with respect to their faces and 1 atom with respect to their simple cubic structure. 1 plus 3 is nothing but completely 4 atoms are existed. In a similar way, BCC, body centered cubic structure. So what is body centered cubic structure? Which is first of all a simple cubic structure. So this is simple cubic structure. Simple cubic is nothing but it is a unit cell and our corners are occupied by lattice points. So this is the unit cell. So corners are occupied by lattice point. So I am taking the atoms. First atom, second, third, 4, 5, 6, 7, 8. So this is the cubic structure. So this cubic structure is converted into which structure? The structure is body centered cubic structure. Body centered cubic structure is nothing but you can take exactly center of the body. You can take one more atom like this. Only single atom is there. How many lattice points are existed? Exactly this center of the body. You can take any cube is the example. Example for cube can be considered as our classroom. Exactly middle portion is linked with any other the unit cell or other the classroom. So exactly middle portion is not linked with any classroom or any unit cell. So entire complete body is existed within the unit cell. So how many lattice parameters there? According to their corners, how many corners are there? Here 8 corners are there. So every corner atom is occupied only 1 by 8th portion. Remaining 7 by 8th portion is occupied with other 7 unit cells. So according to this unit cell, 8 into 1 by 8. How many body center atoms are there? Complete 1 atom is there. 1. So 8 cancel. 1 plus 1 is nothing but 2. So according to the BCC structure, body centered cubic structure, how many lattices or atoms are existed unit cell is completely 2. So according to the completion of this number of atoms per unit cell, you finally got simple cubic structure. How many lattices or atoms per unit cell are there? Only 1. For face centered cubic structure, how many atoms are there? 4 atoms are there. And BCC structure, how many atoms are there? Completely 2. So this is the main one. All are very important. According to this, you can take directly taken for calculation purpose also. Simple cubic structure, only 1 lattice or 1 atom existed in the unit cell. For FCC structure, 4 atoms are existed per unit cell. And BCC structure, how many atoms are there? Only 2 atoms are there. That is the number of atoms per unit cell. Unit cell. So the basic term number of atoms per unit cell is completed with respect to simple cubic, face centered and body centered. After completion of next this one, you can take next topic is atomic radius. Atomic radius, which is indicated by letter small r. Which is indicated by letter small r. According to simple cubic, face centered or body centered any structure, you can take one unit cell first of all. These structures are nothing but first of all one unit cell. So this is the unit cell. So according to the unit cell, every corner is occupied by one lattice point. So this is the lattice point. So according to lattice parameters, the distance between these two lattice points can be taken as lattice parameter or lattice constant A. So according to our data, lattice constant can be taken as A. What are you known? You can take radius of the atom. Radius of the atom can be taken as either small r, sometimes you can take it as capital R as you wish. So first we are relating between lattice constant versus atomic radius. You can derive some relation among the small a versus r, that is the atomic radius. According to definition, you know the atomic radius. What is atomic radius? The exactly half of the distance between neighboring atoms in the structure. In the structure nothing but you can take any structure, simple cubic, face centered, body centered, anything. The nearest distance, exactly half distance, is called as atomic radius. So relation among the small a, nothing but lattice constant versus atomic radius. Though in this structure the relation is derived from first one. Relation between small a and r, small a and r in simple cubic structure. So what is simple cubic structure? Simple cubic structure is first of all a unit cell. Every corner of the unit cell is occupied by one lattice point or atom. Then the structure is called as simple cubic structure. So I am drawing the structure of simple cubic structure is only looking structure. What you look the structure? Looking structure consisting of only three faces like this. Remaining three faces are existing outside. We are assuming so. So according to simple cubic structure, the atoms are existed 1/8 portion, 1/8 portion, 1/8 portion and 1/8. In a similar fashion, 1/8, 1/8, 1/8 and 1/8. In a similar way, 1/8, 1/8, 1/8 and 1/8. This is the representation of the simple cubic structure. So I am shaded the atom's position. What I am shading, that is called as existing atom. So this is the atom. Occupied atom. This is the complete representation of simple cubic structure, and shaded region is called as on that shaded region atom is existed. Remaining white space, this white space is nothing but empty space. That white space is nothing but empty. This region is called as empty region. This shaded region called as existed atom region. So what are required? We are want to calculating the relation among the small a versus r. What is small a? The distance between two lattice points can be taken as lattice constant, that is small a. So you can extend that particularly you can take any one of the face like this. In this face, how many atoms are existed? There are 4 atoms, that is like this. So this atomic structure is repeated like this. Complete atom. This structure is repeated. You can exist the complete atom. This is the center of the atom. This is also center of the atom. So the distance between center of the atom to center of the atom can be taken as, from center to surface of the body can be taken as radius capital R. This is also radius capital R. Nothing but this is 2R. According to the structure, this is lattice point, this is lattice point. According to the lattice point, the distance between these two lattice points can be called as lattice constant A. So according to these two, you can take A can be taken as 2R. So the relation among lattice constant and atomic radius in simple cubic structure can be written as A is equal to 2R. A is equal to 2R. I am taking here capital R. Sometimes you can take as small r. So which is also A is equal to 2R. So the relation among, so radius of the atom is equal to half of the lattice constant. R is equal to A by 2. That is R is equal to A by 2. Nothing but relation between small a and R in simple cubic structure. A is equal to 2R. In a similar way, you can calculate remaining structures also. So first of all, see this. This is the original cubic structure. This original cubic structure is showing only 3 faces, looking faces. You can take the one cube like this. Face 1, face 2, top face. These 3 faces are only showing. Remaining faces are completely eliminated. That is not showing in this structure. Only this is only 3 faces structure. In this 3 faces structure, based on these 3 faces, you can draw the structure of this one. This white space is nothing but empty region. So no atom existed in this region. That is the relation between small a and capital A in the simple cubic structure. Relation is A is equal to 2R. Note down. This is 34. 34.